Hello, everybody. I hope you're having a good day. It was a nice weekend out there this weekend. Super Bowl game was great. I didn't have anybody in mind, so it was just kind of fun to watch. So I hope you had a good time watching it too, if you had a chance. So let's see. This week we're doing some interesting stuff. You'll notice that, well, announcements pretty much nothing. Group project, don't forget your group project. That's coming up, and we'll start getting into where to go from there and all that stuff pretty soon. In the let me bring it up here. In the Xylab for this week. And I hope I can do this. Oh, come on. Okay, so in the Xylab for this, the Zybook for this week, we really don't have a whole lot. We've just got this one part to it. I think there's a PA, but I don't think there's a CA. So that's pretty straightforward. But what there is we're getting ready for those labs. And the labs are going to take more time, and you're going to have to work on those a little bit. But anyhow, so that's coming up. But this week's topic, normalization, is a really important one, and it's one to pay attention to and think about. But let me give you a little background for this. So there's the group projects. There, you've seen that before. So this is the big distinction. So normalization only really applies in cases where we've got business processes, online transaction processing, online transaction processing databases, OLTP. That's the kind of place where we have our e-commerce databases, where we have customer information, product information, all that kind of stuff that are separated out into different tables. And yet we link all those together. Well, those are great for business things. And in business things, that's what we want to concentrate on, keeping track of orders and updates and products and, all of that kind of stuff. But there's a whole nother kind of a database out there, which is online analytics processing, where we really don't care about normalization. As a matter of fact, we denormalize stuff to make it so that we can run our queries faster, because we're only querying one table, which may be a lot wider than the tables we're used to in our online transaction processing, and has a whole bunch of redundant information in it. But because we're not doing all these joins, our queries run a lot faster. So, online data warehouses, which is, kind of a way to think about things. Generally, what happens with a online transaction processing business processes database is that once a week or so, there'll be a big query that runs that grabs a whole lot of data out of all of those different tables and then mushes it all together into one results table. And then that one results table, which is going to be really wide because it's got lots of data in it, is going to be used for doing queries about analytics kinds of things for the rest of the week. And then, at the end of that week, we run our big query again, and then we generate our new data warehouse, and we run more of our our queries against that. So the difference is that business processes, online transaction processing databases, have reads and writes going on all the time. Chop, 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 all day long, 24/7. It's customer information, it's products, it's inventories, and it's all that stuff. But a data warehouse is really different. We'll run those queries to create the data warehouses, usually out of the transaction processing database, and then we just leave it alone. And we don't write to it anymore at all. We just query from it. And as a matter of fact, we don't query it very often, because we've got some managers who have some information they want to find out about. We've got some analysts that want to find out something, some marketing people, that kind of stuff. But the thing is, the data that they require to make their decisions doesn't have to be really up to date. It just doesn't matter. So our data warehouse is generally out of date. It's denormalized. It's really wide, and so it's and we really don't have many hits on it. And the queries that we do have on it, usually we run those pretty much every week. And, they just do their thing and spit out some reports, and a bunch of managers look at it and, try and figure out what's going on with the business. That's the difference between online transaction processing and online analytics processing. Normalization only applies to the transaction processing database. So when we run into this, we get a really different set of workload issues that we have to deal with. As the amount of data gets bigger and the number of concurrent sessions, well, for a data warehouse, the amount of data gets bigger, but the number of concurrent sessions doesn't change. It's still only those small number of analysts that are running their same old queries to feed the marketing machine and other managers and stuff. But that's not the way online transaction processing works. As the amount of data goes up, usually we've got a lot more concurrent sessions going on too. And so that's just going to make for a busier database. Chop, 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 chop. Query, 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 which isn't easy to say. So normalization is a process that we use on those transaction processing databases to try and eliminate redundancy. Now, your book does a pretty good job of explaining this. I posted another document that I've used in the past that I think helps out too, and these slides are taken out of that document. But the first question that you have to answer is, why normalize? And what's normalization all about? Well, normal forms are rules for designing tables with less redundancy. Less of the same information in lots of different tables. So that redundancy can take lots of different forms. Redundant information, why do we care about redundant information? Well, you always, the goal of a database designer is to store the most information in the smallest set of tables. So the smaller we can make our tables, the faster they run, the better they can be used by lots of different data entry people, lots of different online processes, all of that stuff. So our goal is to make our databases small, but contain lots of information. That's where getting redundancy out helps a lot. And another thing, redundant information is a chance for errors in data entry. If you have to type in the same stuff lots of different times, humans make mistakes and our sausage fingers don't work very well at typing. And so if you have to do something 2 or 3 times, you're going to get it wrong. And that can have disastrous effects in a database. Now, cardinality of a field can introduce redundancy also, and they don't talk about this that much in the Xi book. And that's this idea of, if we have redundant information, if we have some tables that require this information, well, the question is, what's the relationship between the number of instances of things that we have? Is it a question of every one of our entries in our customer table has at least one phone number? Okay, fine. But what about where some people maybe don't have a phone number? We sell things to people in the Yukon. And so in that case, you wouldn't have to have a one-to-one relationship between the customer field and the phone number field. And that's a way to cut down on redundancy if you recognize that. So anyhow, that wasn't a very good explanation, but we'll keep on going. So we really have kind of four normal forms that we use, and the distinction between them is pretty straightforward. Now, if you don't get all caught up in the weeds, this stuff isn't very hard to see. But if you do, then you can get all confused and everything. So in first normal form, well, that's really easy. It says all non-key columns depend on the primary key. So if a table has no duplicate rows, and it can't if it's got a primary key, the composite of all columns is unique. So either all columns or some subset comprise a primary key. So first normal form, if you've got a good primary key, you're in first normal form. End of story. Doesn't matter what's in the other columns. If the primary key is a real primary key, there's no duplication. There's no record, customer number 001 that's not in there twice. There's only one customer 001 and there's only one customer 323. Then you're in first normal form. Now, second normal form is a little bit different, but not much. So most of the time, if you're in first normal form, you're in second normal form also. So a table's in second normal form when all non-key columns depend on the whole primary key. In other words, a non-key column cannot depend on part of a composite primary key. So a table with a simple primary key, that means one column is the primary key, is automatically in second normal form. Well, what this gets at is that whole idea of why we generate these fake auto-incremented things like customer number. Why not use the composite of first name, last name as our primary key? Well, we wouldn't be in second normal form very often, or at least it would be a lot harder to make sure that we were, because we'd have two people with the same names. So if you use a simple primary key, one that's auto-generated, that auto-increments, we make it up, it doesn't mean anything, then you're in second normal form. Third normal form, a little bit different, a little more complicated. We're done. Okay, so when a non-key column depends on another non-key column. Informally, a table is third normal form when all non-key columns depend on the key, the whole key, nothing but the key. So if you had a database of cars and one of the fields was let's see, the type of engine that it has. Does it have a internal combustion engine or an electric motor? And so that if a car had an internal combustion engine, it's going to have this other field, which is gas tank size. Then having that second non-key column of gas tank size, every time you have let me say it again. So, blew it. You have a car table, and each car has 4 wheels. And so you have a car entry, and every time there's an entry in the car table, it has number of wheels 4. Then that means that you're not in third normal form, because number of wheels depends on the car entry. So if it's car, it's got 4 wheels. Or if it's a vehicle table and one of the vehicles is car, sorry about this, one of the vehicles is car and the other is truck, Okay, here's the distinction. A truck can have 4 wheels, it can have 6 wheels, it can have 10 wheels, it can have 16 wheels. But a car, if all cars have 4 wheels, then there's a dependency between that entry that says this is a car and this field that says number of wheels 4. Then you're not in third normal form. So in that case, you'd want to take that number of wheels table and put it off into a different field. So every time there's a car, it has 4 in there. Every time there's a truck, 6-wheel truck, it says 6. So that's third normal form. So it's looking at a non-key column depends on another non-key column. Every time there's this entry, there's this entry. And that's where you're not in third normal form. To get around that, you'd want to create a secondary table to transfer that information into the secondary table. Now, Boyce-Codd normal form, which is basically as far as you go. There's a fourth normal form and a fifth normal form and a couple others, but we really don't use those in business situations. Remember, this is all about transactions, so this is about business in large case. So in Boyce-Codd normal form, if when column A depends on column B, then B is unique. Columns A and B may be simple or composite. The definition is identical to the definition of third normal form with the term non-key removed. So third normal form, non-key column depends on another non-key column. Boyce-Codd, we take that non-key part out and say any column depends on another column. And so, that's the big distinction between Boyce-Codd and third normal form. Now, as you go through the exercises in the Zybook, you're going to have some of these normalization questions. What do we do when we have these two things that depend on each other? That this one's always, this one is always this value if this one is this value. That's where we're going to start breaking things up and coming up with multiple tables to store our data. So the normalization process involves 3 steps. List all the unique columns. So write down the columns that you want to have. They may be simple or composite. Remember, composite is the sum total of the information depends on more than one column. So the 2 columns determine something. Remove any columns that are not necessary for uniqueness. The primary key is unique and therefore always on this list. So you start out, first you look at your table and you say, is it in first normal form? If it's got a primary key, it's in first normal form. Then you look at your table again and you say, is it in second normal form? And if your primary key is a 1-column primary key, and it's auto-generated, it doesn't mean anything, it's just a customer 001, that kind of a primary key, then you're in second normal form. The next thing to do is to look for third normal form. Am I in third normal form? And that's where you're looking for dependencies between non-key columns. So if this non-key column, if this one over here always is the same value, if this non-key column is this value, that's not in third normal form. Then you're going to have to take one of those columns out and create a secondary table. Now, the next step is it in Boyce-Codd normal form? And that's where you're looking at the primary key and saying, is this determinant of any of the values in our other columns? That's, if it's not, then you're in Boyce-Codd normal form. So you start with first normal form, look for the primary key. If it's good, you're good. Then go to second normal form. Is my primary key a composite key, or is it a single meaningless primary key? If it is, great, you're in second normal form. And that's how you go into third normal form, looking for dependencies between non-key columns, and then into Boyce-Codd normal form, looking for dependencies between the key column or columns, and any of the values in the table. So that's kind of what this says. So identify dependencies on non-unique columns. Non-unique columns are either external to all unique columns or contained within a composite unique column. I know that's confusing. I try to, put it in words for you that make more sense to me, and eliminate dependencies on non-unique columns. And that's it. And then normalization eliminates redundancy by removing A from the original table. Since data relating A and B is recorded in a new table, no information is lost. So that's what normalization is all about. And let's see, so what else we got? I think that's it. Have a good week, everybody, and I hope this helps. Remember, if you're getting confused or behind or something like that, stop by and see me. I'm around, or email me. I try and get back to you pretty quickly. So take care, everybody. Have a good week.